So hello friends, it is my lecture 9th. Okay, so it is my lecture 9th. Okay, lecture 9th. Okay, and related to general organic chemistry. And in this lecture I will discuss the application of inductive effects. Okay, application of inductive effects. Okay, application of inductive effects. Okay, so friends, if you see here, I have discussed the before. Since I am going to discuss the uh, which point, I think it is my third point. Okay, third application, which describes the relative strength of relative strength relative strength of acids. Okay, before this, I think before this lecture I have described the relative strength of alkyl halides. Okay, so I will take example to explain this, how you determine the relative strength of acid. So first of all, you should be I will draw the structure. Suppose that this one CCl3 Cl COH. Okay, COH. Okay, so first of all, what first of all, you will be open the structure. Okay, so what is the structure in open form? If you see here, this is the 3Cl is attached 3Cl is attached by carbon atom. Okay, so I think it will be not happen here. So it is the COH. Okay, and it is the Cl, 3Cl is attached by carbon atom. Okay, so what happened here? Okay, so first of all, you should be know the what is the relative strength of acid. Okay, means which acid containing molecule, which acid containing molecule easily donates the H plus. Okay, in the medium, in the reaction medium, you can say. Okay, reaction medium. Okay, so it is a simple definition of relative strength of acid. Means what is the relative strength of acid means. So by this point you can explain this. Okay, so I will describe the relative strength of this molecule. So in this molecule, if you see here, these are the chlorine is the electron withdrawing, means it attracts electron of this carbon. Okay, and this carbon means this carboxylate ion, the electron of these molecule, because electron density is much more here. Okay, so that's why electron will be transferred from this carbon to this molecule. Okay, understand? So since here 3Cl is present and it is electron withdrawing group. Okay, so it attracts, actually what happen here, if you will break this molecule, so it will break into this one. Okay, H plus in the reaction medium. Okay, so what happened here, when these chlorine atom attracts electron from these carboxylate anion. Okay, so charge density will be less here. Okay, so that's why what happened here, the interaction between this oxygen and hydrogen become less, so it donates, it means it release H plus very easily. Okay, understand? So means, okay, so it is the concept, you can say it is, by this concept you can identify which molecule will be release H plus easily and will be strong acid. Okay, so in this case, if you see Cl2 CSCOH. Okay, so if you open the structure, what happened, there is 2Cl. Okay, so 2Cl. So that's why electron means it attracts electron but less extent as compared to this molecule. Okay, so that's why it will be less acidic as compared to this. Okay, but in this case what happened here, CH3 COH. Okay, so what happened here, these are the what happened here, CH3 is the electron releasing group, so that's why electron density means it donates electron to carboxylate. That's why charge of carboxylate anion will be, you can mention here, charge of CO minus will be higher. So that's why interaction between these hydrogen and oxygen interaction, what happen here, interaction between oxygen and hydrogen will be higher. So that's why it will be less acidic. Okay, so that's why less acidic. ओके, इंट्रैक्शन ज़्यादा होगा मतलब H प्लस रिलीज नहीं करेगा, H प्लस विल नॉट रिलीज. Understand? So it is the concept behind the relative strength of acid. Okay, so order will be the first, suppose that it is first, okay, then second, then third. Okay, so if you see here the question in the examination, in the exams, question will be asked like that, order of acidic strength among the molecule. Okay, so what happen here, suppose that I will draw CH3 का whole twice, CSCOH, CCl3COH, okay, and CH3COH. So what will be the order? Suppose that this is A, this is B, and it is C. Okay, so option will be, so what is the order? If you see here, it is electron withdrawing. How much electron withdrawing group is attached? 2. Okay, so that's why it increases the charge density of carboxylate ion. That's why it will be not release H plus. Okay, but in this case CH3, there is one CH3, so that's why charge will be transfer as compared to this will be less. But in this case Cl3, 3Cl3 is there. Okay, 3Cl3 is there, so that's why electron will be withdrawn of these, means charge density will be withdrawn by these chlorine atoms. So that's why these attraction between oxygen hydrogen will be less and it will be more acidic. Interaction between oxygen and hydrogen will be less, that's why H plus will be released. Okay, so order will be the first B, then C, then A. So it is the relative strength of acid. So it is the relative strength of acid. Okay, so it is very important question for IIMS, okay, and IITs. Okay, and also it can be asked in NEET exams. Okay, so it is all about the acidity, means I have explained these acidity means application of inductive effects under this relative strength of acid I have explained. Okay, so the next point is that, so in this, if you see in this, so I have actually discussed the relative strength of acid. You can also one point is that, so in this concept there is two main formulas. What is formulas? Okay, so means electron withdrawing group, okay, such as chlorine, NO2. Okay, so these are the electron withdrawing group. So it is directly proportional to acidic strength. Acidic strength किसकी? ऑफ कार्बोक्सिलिक. okay, but electron releasing group is inversely proportional to acidic strength of acids. Okay, so it is a two formulas. By these formulas you can solve your question. Okay, it is very important formula for determining the acidic strength of acids. Okay, so next point I have explained the one point actually if you compare from this molecule, suppose that SCOH CH3COH. Okay, so electron release H plus means it in some extent it will donates the electron to this molecule, but in this three molecule of hydrogen is present. Okay, so that's why it will more acidic as compared to this, so it is very important also. So next point I have explained the what, if you see here, so I have completed this point, relative strength of acid, and next point is relative strength of base. Okay, so I have explained this relative strength of base, relative, so it is my fourth point. So relative strength of base, so it is also application of inductive effect by which you can identify the relative strength of base. So suppose that I have taken example NH3 का ammonia, okay, then CH3 का whole thrice N, okay, then CH3 का whole twice NH, okay. So among these molecule I will determine the basic strength. Okay, basic strength means what happen here. First of all, you should be understood the term basic strength. Okay, so it is the means which molecule in which nitrogen feel maximum electron density is known, is called basic strength. Okay, so okay, so it is the, suppose that this molecule ammonia, so first of all I will draw the B. Suppose that this is A, this is B, this is C. Okay, so what happened here, this is the CH3, this is the CH3, this is the CH3, it is the lone pair of electron. Okay, why I have mentioned the lone pair of electron, because each and every atom want to complete its octet. Okay, so nitrogen having 8 electron. Okay, so that's why 2 to 4 to 6 to 8. Okay, in this molecule what happened, actually it is able to donate its lone pair, means this molecule itself having lone pair. Okay, means nitrogen having lone pair, it is already basic, but when it is attached by CH3 3CH3, electron density will be much more. Okay, much more means these electron flows towards means nitrogen. Okay, so nitrogen feels electron density much more, that's why the electron density towards nitrogen will be maximum. Okay, so it is means basicity will be higher, basicity will be higher. But what happened here, in this molecule these are the groups which is very crowd, means towards nitrogen, so a crowding type nature has been created. Okay, so this is called steric effect. Okay, since due to steric effect it feels some amount of, means some extent less basic character as compared to diethylamine. This is dimethylamine. Okay, so if you see here in this molecule what happened here, in this molecule. If you compare in this molecule, first of all you should be know about that. So in this molecule, if you see, I mean it's not total. Yeah, one point is mentioned here that the relative basic character of amines is not in total kind of inductive effects, tertiary, secondary, primary. Okay, but it is the following order: secondary, primary, then tertiary. The region the steric existence of molecule. Okay, so actually I want to say that, sorry, actually I want to see the this type of question, but there is no question. But if you see here, so it is the, so as compared to this molecule, it is so less basic character, because in this molecule two molecules of methyl, that's why crowding is steric effect does not proceed. Okay, so that's why it is much more basic as compared to this. Okay, so first order will be secondary, tertiary. In ammonia there is no methyl group, so that's why it will be less. Okay, so order will be this one. Okay, so order will be, if you see here, first of all C, then B, then 1. So order will be this one. Okay, i I have also taken another example, diethylamine, triethylamine. Okay, and ammonia. Okay, actually it is also mentioned here, this one. Okay, diethylamine, ethylamine, methylamine. So these are types of, means also in this book examples have been mentioned. So if you see here, in this molecule, this is dimethyl, this is trimethyl, this is ammonia. Okay, so in this molecule what happened here, actually I have take this simple example. First of all, C2H5 NH. Okay, C2H5 NH2 and ammonia. I have taken this example first of all. Okay, in this molecule dimethylamine means it donates electron to nitrogen atom. Dimethyl, if you draw the structure, it will like that. It donates electron to the nitrogen. Nitrogen having already lone pair of electrons, so that's why it is more basic as compared to this molecule. Okay, but amine will be less basic. Okay, so it is also important question for IIMS and IIT point of view. One question from this molecule also can be asked. Suppose that this molecule is present here, after that this molecule, this is oxygen. Okay, this is, okay, and other molecule is also, suppose that this one. Okay, so this is aromatic. So in this molecule, suppose that this is A, this is B, this is C, this is D. So which molecule is more basic? So question will be asked basicity. Okay, it is very important question, you can say, for IIMS and IITs level, OIMS and IIT. Okay, so what happened here, first of all you should know about the aliphatic amine बेसिडिटी क्या होती है एलिफेटिक की, ज़्यादा होती है एज कंपेयर टू किसके, एरोमेटिक एमीन. Aromatic means one arrow. I have mentioned one arrow here, three arrow means this is more basic as compared to aromatic amine. In this case, what happened here, this molecule, actually if you see this molecule, these are the aliphatic carbon atom. It donates electron to nitrogen atom. Okay, so that's why it is more basic. Lone pair is also free, and it feels that it accepted the electron from these these aliphatic carbons. Okay, so it will be much more basic as compared to this. 2 is the aliphatic. Okay, so if you see here, this is the oxygen atom. So why it is less basic as compared to this? Since oxygen is present here, so it also attracts electron from these carbon atoms. Okay, so that's why it the means electron density will be less as compared to this in this position. So that's why it will be more basic. In this molecule, what happened here, since 2 is more basic as compared to aromatic amines, in this molecule one lone pair is present here, it is free, but in this molecule this lone pair of electron takes part in resonance. Okay, so that's why it will be less basic. Okay, so after that it will okay, so it is very important question and can be asked in several exams, competitive exams, so you will be try to solve this. Okay, so next question is that I have also one question also mentioned here. Suppose that Cl2 NH, okay, Cl NH2, okay, and amine, which is the more basic? Suppose that this one is A, this is B, this is C. So suppose that if first of all you open the structure, tick. So here lone pair of electron is also present. Chlorine is electron withdrawing group. Okay, it attracts electron towards one side. Okay, so that's why nitrogen feels less electron density. Okay, so that's why it will be less basic as compared to this. Means क्या इसमें क्या हुआ कि जो concept आ रहे हैं आपके, the two concept is most important for that. Electron releasing group, okay, is directly proportional to basic strength. Okay, but electron withdrawing group is inversely proportional to basic strength of किसकी? amines, basic strength of amines. Okay, so it is the basic strength. So I have explained the basic character. Okay, after that the third point is it also basicity of alcohols. Okay, so if you see here, basicity I can also explain basicity of alcohols. Before this I have explained the basicity of alcohols. Okay, suppose that this is CH3 का whole thrice COH. Okay, CH3 का whole thrice COOH. Okay, this is COH. CH3 का whole thrice Cl3 का whole twice, then you can CHOH. Okay, CHOH. Okay, and CH3 COH. So what is the basic strength? In this is the I have mentioned the two formulas. Electron releasing group increase the basicity of alcohols. Okay, so sorry for this is carboxylic acid, actually sorry for that. CH3 का whole thrice COH, since 3 this one. Okay, CHOH, हाँ, okay, CH3OH. Okay, so in this electron releasing group, so that's why it increases the basic strength. Okay, so it will much more basic, then it will basic. Oh, okay, so it is also very important question. Okay, so again stability of carbonium ion. Okay, it also explain the stability of carbonium ion. Stability, it is the I think fifth, the sixth, it is the seventh. Okay, so stability of, it is the 8th one, stability of, it also explain the stability of carbocation. Okay, suppose that carbocation which type? Tertiary. Either carbocation will be tertiary or secondary or, so order will be, suppose that this CH3 का whole thrice C plus. Okay, CH3 का whole twice CH. Okay, and this is CH3 CH3. What happened here? CH3 CH2 plus. Okay, so in this which will be the most stable? So tertiary will be more basic, then secondary, then so what is the actually fact is that suppose that these are the electron releasing group. Okay, electron releasing means it donates electron to carbon feels less charge, means it is already electropositive, so electropositive character will be released by these electron given by methyl group, so that's why it will be the more stable, then it will be stable, then it will. Okay, so it is all about, and one point is remain stability of carbon and carbo, stability of carbanion. Okay, so it is my point, I think it is the 8 point, it is the 7 point, it is the 8th point. Okay, so stability of carbanion. Okay, so what is the idea? Actually it is reverse from that, because suppose that minus charge is given here, so already carbon plays more electron. Okay, much more charge, and already, and then cs3 is also donates electron, so it feels instability. Okay, so that's why order will be the first of primary, then secondary, then tertiary. Okay, and it is the, I have also mentioned the molecule like that, cs3 the whole twice, ch cs3 cs2 minus. Okay, so it is the, suppose that it is first. Okay, so it is the order will be like that, first of all it will be, then it will be, then it will be. So order means first, second, then third. Okay, so it is the stability of carbanion. Okay, so it is all about actually so today I have